great speakers to share their expertise on SPSS, Brittany and Margaret, right?
Yes.
So thank you very much. We'll turn the floor over. And let me know if you need me to pass out. Is this?
Yeah, that's the handout. Anyone, if you
Okay.
can take one,
You got one.
you can follow it or just look at the screen. Have you started recording?
Yes.
Okay. I just want to say we are the research assistants of CIRC, which is the Center for Interdisciplinary Research and Consulting. We help people with their statistical and mathematical problems for their research projects, and we also do a lot of workshops. I want to show you the CIRC website really quickly, because if you're interested in learning more programs, we actually offer free workshops. If you click on fall 2011, here's the schedule. Tomorrow we have Excel, and we have all other workshops for these different programs. You're free to come and get an introductory level learning. So I'll just minimize that. Okay, everybody has their SPSS open, right? And you got the... Oh, okay. But did you download Profit Excel file?
Excel.
Oh, okay. Okay. Well, the first thing we're gonna do is import the Excel file called Profit. It's kind of. Okay, if you go to, one second. If you go to File, and then go on Open, and then go to Data, okay, we're going to import an Excel file, so we need to select Excel. And then here's under my documents, I already saved the Profit file, so this is what I'm going to click on. And then, okay, the next we know, you need to make sure you check this read variable names from the first row of data, because our first row is actually the column names, it's not the data. So once you click it, its default is actually already clicked. You can also import a range of data, but in this case we are importing the entire data set, so we don't have to specify a range. And then just click on OK. Okay, it looks similar to Excel. It has the variable names at the top and then the data here. I will tell you a little bit about the data set. It won't really matter that much, but this is district. It's almost like an ID number. And Pro is the profit area. I think it's like the square footage or something like that. And the next one is population. The next one is outlets, and the last one is commission. Sorry?
The data set is about housing then?
I'm not really sure what it's about. It could be housing. It's something like that. Okay. But I mean, it doesn't matter. It's just a data set we're going to use to experiment. So now we're going to define the variable properties. So when you import a data set from Excel or any source, sometimes the variables are not defined correctly. So that's what we're going to do now. If you go to data and then define. Oh, by the way, I need to mention this. This handout is for the version 17, but we're using version 19, so there might be some differences. I haven't used 19 before, so, I mean, if there are some differences, it could be due to that. So, if you click on Define Variable Properties, okay, so we're gonna, you can just double click or use this arrow here. And then click Continue. Now we're gonna. The first one selected is the district. So you need to make sure it's selected. We're gonna change it. It's already scaled. So that's good because it's supposed to be scale. Oh no, it's supposed to be nominal, right? Okay.
Same thing as categorical.
So the next one is profit, and we want profit to be scale. So we're going to change it to scale. Right, yeah. And then area is also going to be scale, so that's correct. And population is a scale. Scale, and the commission is going to be nominal. And for commission, you can add label. This in the commission column, you can see zeros and ones. So 0 means no, meaning no commission. So I will just type in no, and yes for the value 1. This is how you add the label. And I think that's all we need to do. If you click on OK. Data. Okay.
From the Rsquare website?
Mm-hmm.
I can work with it.
If you can download the profit under SAS, that's the one I did.
The
They
SAS
should,
one.
yes.
I went to the SPSS. Okay. Alright. No problem.
I mean, yeah. Right.
Got it.
Okay, so if you click on variable view, you can see the names of the variables and their types. So just to make sure they're correct. So I will go back to the data view. Now, once we have the data, the next step is usually to create a histogram to see what the distribution looks like. So to do that, if you go to graphs, right here, chart builder. Okay, here a window pops up saying that you might want to define your variables, but we've already done that. So you can just say, okay. Oh. Now this is the chart builder window, so we're going to create a histogram. So let's say we want to, we need to select histogram here, and it will give you different options, so you can pick any one you want. I mean, we'll just show you to create some charts, but you need to explore a little bit more just to create different types of charts, whatever you want. You just need to explore a little bit more. So if you click on this, the first one, and drag it here. Okay, so this is the bar chart. We just need to define what's going to be our, let's put this here. Okay, so we're going to create a histogram for profit. There you go. You just drag the pro to x-axis, and it's going to create the histogram. Now you can make changes on certain things. You can change the x variable, y variable name, so change the label. So if you click on it, it will give you some options. You can just explore those. And here we selected histogram. You can select different options like percentage, count, cumulative count. So if you're creating a different histogram, these are your options that you can use.
Where does that show up, sorry?
Which one?
Where does it show up that you can choose histogram or other things?
Here it says statistic, histogram. Do you have the element properties window?
Mm-hmm.
Okay. There's a drop-down menu here that says histogram. What does it say there?
Oh, we have the other one. Okay, sorry. I was on x-axis.
Okay, so, and if you click on the display normal curve, it will do that for you. And you say apply. And then if you come back here and click on OK, you should get a, okay, here it is. Here's our histogram with the normal curve. If you want to make changes on your histogram, you can just double click on it, and it will give you some options. You know, change the color, height, and all that kind of stuff if you want to make changes on it. Let's see. Now let's create a box plot. If you go to, again, you go to Graphs and Chart Builder. This is where you create all your charts, so you just choose different options. Here's below here, there's a box plot option. Again, you just drag this one here. It will show you the preview. And now we need to drag the x-axis and y-axis. In this one, commission is going to be our x-axis, and profit is going to be our y-axis. Okay. Everything else is pretty much the same like we did in a histogram. Again, you can click on the x-axis, y-axis if you want to label them. And you can also add titles if you want to. Here you can add titles, subtitles, footnotes. So you can make it look prettier if you're going to present it somewhere. So there are some additional options here. And if you click on OK, okay, here's our box plot. Now let's say we want to, well, I mean this should give you an idea of how to create any kind of chart. The next step is usually creating descriptive statistics. To do that, you need to go to Analyze, Descriptive Statistics, and Descriptives. Now let's select population. Let's see. And I don't know. Let's check. And profit. So we're going to get the descriptive statistics of these two variables. You can select more than two and any number you would like. And click on OK. Yes, I was going to show you something else too. Let's go back here. Descriptives. If you click on options, here you can see different descriptive statistics, and you can click on the ones that you want to see, the mean, sum, standard deviation, range, variance, any one of these you would like to see. You just need to click on it, and then it's going to show you. You just click on continue and OK. See, this one also has the sum because we added it, but everything else looks the same, and we have these two variables. Let's say you have a set of data and you want to see if it's normal distributed. You can check that by creating a QQ plot. If you go to Analyze, Descriptive Statistics, and plots. Okay.
Just click on, sorry.
QQ plot.
Okay.
What was QQ plot?
It shows you, when you look at the QQ plot, it's going to show you whether it's normal distributed or not. We're going to create one and see if it's okay. And if you click on OK, okay, if your data is lined on this, you see this line. If your data is on it, it means it's normally distributed. Any deviation from that line means that your data might not be normally distributed. So if you ever need to check for normality, this is what you can use.
How will the data look like if it's not normally distributed?
Sorry?
I mean, how the data will look like?
You see our histogram we created? See, that's how our data looks like, and this is our normal curve here.
What I mean was, what is when the data is not normally distributed? How the line look like?
Well, it could be exponential. It could be a different distribution. So it could be an exponential distribution. There are so many different distributions that it could be one of them.
So the one we have here, this is a normal distribution? I mean, some of the circles are not on the line, but they're
Right.
close enough, right? Are they close enough or they're not close enough?
I don't think it's normally distributed. No. No, there's a lot of deviation. You see there's a pattern. So I wouldn't call it a normal distributed.
So this is what it looks like. Answer the question.
Especially paying attention to the tails. It doesn't look good.
Yeah.
Oh, because there's one totally off.
Okay, the next we're gonna do hypothesis testing for mean. So in this one we're testing for profit. Our null hypothesis is our mean profit is 900 versus our alternative is not, our mean profit is not 900. So you go to analyze and then compare means. And then we're going to do one sample t-test.
You've sort of seen this before with your box plots. The averages look like they're different, but we're actually going to test it now.
Yes, and this is a one sample t-test because you're just looking at one sample. If we were comparing two samples and check whether their means are equal, that it would be a two sample test. So again, we're going to test functions and then click on options. We're looking at 95% confidence interval. And then and test value, we are testing whether it's equal to 900 or not. So we need to change it to 900 and click on OK. Okay, you can see that. Okay, let's see here. Yeah, it's the same. So you can see that our confidence interval doesn't have 900 in it. So which means we can reject the null hypothesis. We can also look at the p-value for a two-tail test, and it's very small, it's almost 0, which means you can reject the null hypothesis, which means the average is not equal to 900. And our t-value is 4.38, so it's a big enough number. So we rejected the null hypothesis. Any questions? Okay. Okay, the next one we're going to do is we're going to test for equality of two means. So let's see. If you go to, we're going to go to analyze descriptive, no, not the descriptive statistics, but compare means, yeah. Independent samples t-test. Yeah, we're going to select the independent samples t-test. Okay, we select profit as our test variable, but we want to see the mean profit for commission. There are two commission types, so no commission and commission, and there's commission, so we want to test the mean of profit for these two groups. So commission is our grouping variable, and again we want to check it's 95%, that's good, and we can define the groups. Group 1 is 0, so if commission is 0, that's our group 1, and group 2 is 1 when the commission is 1. So continue, and that should, okay. Now you will get two tests for depending whether you know they have equal variances or not. You can make that assumption, and you can make that assumption based on what you know about your data. So you might have prior knowledge about the variance. But if you don't assume that, you need to look at the second one. Now we can look at the p-values, and you can see it's pretty close, but you can still because it's two-tail test. It's larger than our alpha, so you fail to reject the null hypothesis. That's the idea. And our null hypothesis was the average of the first group is the same as the average of the second group. So we failed to reject that null hypothesis. And the two might give us slightly different results, but it depends on what you know about your variance. You can use either one of those. Okay. Okay. The next one is, what we're going to do next is constructing a scatter plot of two variables. Again, to create graphs, we go to Graphs, Chart Builder, and then one second. Okay. We can select this one and drag it here. So it's going to replace the histogram, and we need to select the X and Y. So area is going to be our x-axis. So if you can drag it down here, and profit is going to be y-axis. It's already that, and this is going to be our scatter plot. You can again make those changes that I talked about before. You can change the statistic here. You can change the labels of x and y-axis. You can add titles, footnotes, so you can make those changes. And I'll just click on OK.
Can I ask a question?
Sure.
Are you, with each one of these things that you're demonstrating, putting it in the same output file and just keeping this going from one thing to another?
Yes, yes, it's all putting it one after another. If you scroll up, you will see everything we've created before.
Okay.
But you can copy and paste these anywhere you like.
I know that, just in terms of how you're switching from a lot of different things, and in terms of tracking it, you're just keeping it all in one output area. Is that how you would normally do this?
Well, this is really how SPSS does it. You mean like if with different programs, or?
With each function, would you have a separate output, or would you just put all of the functions in just one output file?
Well, once you start the analysis, you start with one thing, but you do like create a graph and do a testing or something else, so it would be all in one.
Okay.
Yeah. Yeah, it has a list of everything we've created if you want to go any of those, but okay, now we can create a scatter plot matrix. Let's say if you have more than two variables, so that's when you can use scatter plot matrix. Again, we go to Graphs, Chart Builder, and then let's see. Yes, you pick this one. This is the scatter matrix, and then yes, then you add these variables here: profit, area, and then population, and outlets. If you click on OK, what it does is it creates a scatter plot for each combination. Here, like profit with area, population, and outlets, and the second one is area with profit, population. And you can see if you look at the off-diagonal graphs, this is exactly the same as this one, except that it's in reverse order, but the idea is the same. So if you have more than 2 variables, you can use the scatter matrix to create scatter plots. Do you have any questions? If you have any questions, feel free to ask anytime, or Brittany can help you too.
Quick question. So you could do something similar with like gender, GPA, and ethnicity, or something like
right.
that.
Yeah. You just, but your data should be like, yeah, you can do it. Just continuous.
A good idea of how the data are related. If you're looking at these, and you can look at 2 of them and say, like outlets and population, it looks like they're linearly related. And then you can go on from there with your analysis.
But, and also, to create a scatter plot, you need continuous data. If you have gender, that's not going to give you something like that. It will give you for each subgroup, but then you need a continuous variable. Okay, next we're going to compute the correlation coefficient. Let's say we want to compute the pairwise correlation coefficients among variables profit, area, population, and outlets. So we go to analyze and then correlate and bivariate. And then we select area, population, outlets. We select all these variables we're interested. And there are different types of correlation coefficients. Depending on which one you want to use, you can select that one. We're going to use Pearson. It's widely used, so we're going to go with that one. Let's say you want to look at the correlation, but you also want to test whether these 2 variables are correlated. You can do that by specifying whether it's a 2-tail test or 1-tail test. 2-tail test means it's your alternative hypothesis is not equal to, so whether they're correlated or not. So let's select that one and then click on OK. So correlation ranges between -1 and 1. -1 means negatively correlated, perfectly negatively correlated. If it's +1, it means positively correlated, and it ranges between these 2 numbers. So if it's higher, it's close to absolute value of 1, it means there's high correlation. If it's close to 0, there isn't correlation, or there's very little correlation. But there's no really a set number that you can say it's below this, above this number, but you can just judge based on the data you have. Right. So you can see there's negative 0.696 between profit and area. It's moderate. Again, it depends on what kind of data you have. You can find it strong or not strong, and it also depends on your the size of your data set. If you have a large data set, then even smaller numbers might be like, you can see it as a correlation, rather than if you have small data set, then you would expect to get higher numbers. You would need higher numbers to say that they are correlated. And again, these numbers are exactly the same as this one, because looking at area versus profit is the same as looking at profit versus area. So those numbers are the same. And here's our p-values. You can use these p-values to say whether to reject the null hypothesis or not to reject the null hypothesis. So the null hypothesis is that we have correlation. And if you have small p-value, it means you can reject the null hypothesis, which means there is a correlation. And this is what you can use. And I think all are kind of correlated. But our sample size is smaller. So it depends on your data set. Okay, next what we're going to do is create do a linear regression. Again, for all these statistical analysis, you go to Analyze in the menu, and that's what we're going to do. We'll go to Analyze, and then Regression, and then Linear. Now, in this case, our dependent variable is profit. So we are trying to, in a way, we're trying to estimate the profit by using the other variables, the independent variables. So you can just drag it here. And then our independent variables are area, population, and outlets.
So what are the symbols for the top and bottom of those copies in the left column?
These are, when we define the variables, depending on what you define it, how you define it, it's going to put a symbol just to remind you what it is. This is for nominal, and the next one is scale. So if you change the variable, it's going to change the icon. Commission? Yes, commission is in there too, right? Thanks. So now we have 4 variables in there. There are different, when you run a linear regression model, there are different ways of running it. Let's say you have many variables, independent variables, and you can use different methods like stepwise, remove, backward, forward. It's just different method of running a regression model. If you use forward, it would start with the most significant variable, add it into the regression, and then add the second most significant variable and add it to your linear regression. It would do it until all the variables are included if they are significant. And backward, what backward does is it includes all the variables, all your independent variables in the model, and then take them out if they are not significant. So these are different methods. Depending on which one you want to use, you can just select one of them. We'll just keep it entered. We're not going to do that, but you can do it if you like. If you click on statistics, we want to see the estimates and the confidence intervals at 95% confidence limit and collinearity diagnostics here at the bottom. And I think that should be enough. And continue. If you click on save, when you click on save, it allows you to choose whether to save or not several of these quantities. You can save them. We're going to select unstandardized, standardized, and here for residuals we're going to click on standardized, standardized, and mean prediction intervals mean. And we will also include the covariance matrix. Click on continue. And if you click on plots, it's going to give you different options depending on what kind of plots you want to create. You can choose whichever you like when you do your linear regression. Just do that and then click on OK. Okay. So it gives you the list of variables used for your linear regression. It gives you the R-square, which is 0.66. R-square tells you the how much variability in your dependent variable is explained by your independent variables. In this case, we have 4 independent variables, and our dependent variable is profit. If you look at the ANOVA, you can see that our F value is 22 and our P value is very small. The null hypothesis here is that all the regression coefficients are equal to 0, meaning none of the independent variables are useful in explaining the variability in your dependent variable. So if it's very small, it means at least one of the independent variables, it could be more than one, but at least one of them is actually good at explaining the variable, explaining your dependent variable, your profit. So that's a good thing. But you want to know which ones are significant, which ones are not significant. So you need to look at the t values. This is constant is our intercept, so you can kind of skip that one. But by looking at the p values here for each of these variables, you can say whether area is actually significant or not. Because this is less than 0.05, we can say area is useful. But our population is like 0.10, so depending on your confidence limit, if you want to use 95% versus 90%, depending on what you want to use, this is, in our case, we use 95%, so it's not significant. So population is not significant. Commission is not significant, but outlets is not significant. So you might want to take these out of your model. And there are other diagnostics that you create. You can take a look at these to see if it's going to help you with your model. Collinearity means your independent variables should be not be correlated with each other. So your 4 variables, if they're correlated, if they're related, then that creates a collinearity problem. So you might want to check some of these just to make sure your model is correct. And it also gives you the residuals for your linear model. If you go back to your data set, you can see that we originally had all these 6 variables. Now, because we saved some of the statistics, now it's going to save it in your data set so that you will have access to this data later if you want to analyze it. So that's the step where we did the save. Click on save and select the different options. And if you click on the variable view, actually you will get some information about which variables are added. So just because these are kind of hard to understand what they are, you can read the label so that you know what they are for. Now, if you go back to data view, now let's say we want to save this data with the additional columns. If you just go to File, Save As, and then you can save it in your documents. You can rename it. I'll just save it this way. But this is how you save the new data set. If you want to save,
where are those columns defined in the new data set?
where are
the column headings that you have there? What, no. Yeah, okay.
Yeah, if you go to variable view, it's going to tell you all the list of variables and information, what type of data and all the labels, all that information. So let's say we would like to save this output. We have created all these tables and charts. We want to save it. If you go here and then go to File, Save As, Now, this is going to have an .spv extension, and you can rename it as you like, and you just click on save. And again, I'm saving these in my documents, but you can save it anywhere you like. And the last thing I want to show is, this is pretty much all we're going to cover, but SPSS, you can use SPSS help to get more information about some other functions and some other utilities. So if you go on help, and you can do tutorials, which can be very helpful. If you're new, you can go over some of the basics, and then it will give you data sets so you can apply what you learn. And so it's a good way of starting to learn SPSS. And that might be a good way to, and you can always go to topics and search for specific functions if you need help. So also SPSS has a website. It has, you have it on your handout. You will see the link to the SPSS help online, so you can use that too. Do you have any questions? Again, we will have another SPSS workshop. If you go to CERC's website, you will see the exact date. They're all on Wednesdays at noon, so you can always go to those to review. Or if you want to learn any other program like SAS Enterprise Guide, it's also point and click. We also have SAS, which is programming. If you like to learn that, you can also go there. Or if you're in math, you know, if you need to learn a mathematical program, we have MATLAB and other programs. So that will be it for now. Any questions? I don't know. Honestly, when we did this, I had the 17, so now it's 19. Okay, but I mean the looks doesn't change that much. I mean, if you look at the handouts, it's going to be very similar, and this is 17 versus 19. It's almost identical. So this might have some good features, additional features, but I haven't used this either, so I can't really tell you. But I don't think it's going to be that different. Okay, well, thank you for coming. Thank you. Oh, thank you. Oh, also, could you, before leaving, if you could fill out these, I would appreciate it. We do this for all of our workshops. Thank you. You don't need to write your name. Just